Generally, starters are known to be a critical component in an electric motor setup. This setup is what actually distinguishes the motor to be used in critical and non-critical environments, that is in factories or for domestic use. Again, it is also synonymous with the motor size. And of course, motors of large ratings are mostly found in an industrial setting while the lesser ones are found in homes and other domestic settings.
Of course, starters are one of the major ways of keeping our electric motor in good working order. So, in order to achieve this, many devices are used to optimize function, and as well to safeguard against common complications and issues which are related to the electric motor in general. The tools that are used to achieve all these is what is known as starters.
Another thing worth noting is that they can also be known as devices that are primarily used for starting and stopping an electric motor reliably.
The way this device behaves is quite similar to an electric relay. Relays are used to control the state of the connected load. That is to switch on or off at interval.
Unlike relay, the primary function of starters is to safely start or stop a motor, or to reverse the direction of rotation, and to protect the device from low voltage and overcurrent. So basically, motor starters are utilized to mitigate and prevent electrical overloading. Again, if those risks are not properly taken care of, it can lead to serious risks to assets and employee health.
One of the most common ways in which the motor can be vulnerable to risks are electrical surges occur due to weather, sudden change in electrical use within your facility, and incompatible load, which are the load that is higher than the rating of the motor.
So basically, starter act as the first point of defense. That is by first controlling the connected load or equipment at its initial point of operation. And it also act as a failsafe. That is, if the electrical output or current exceeds the safe limit of your starter, the motor starter will deactivate the electric motor or the connected load.
Electrical starter can be divided into two, which are starter with moving parts and starters with non-moving parts. Now let's look at starters with moving part in detail. This consists of the following parts: contactors, overload, push button, and terminating cables. While starters with non-moving parts are Denfos VLTS, Synamics drives, PowerFlex, Acapus drives, and to mention a few.
The major difference between both starters is in starters without moving parts, which can also be known as soft starters, current sensing is done via electronic means, which means that an overload relay might not be needed here. Solid-state starter offers control starting of the electric motor. Of course, the possibilities of this evolve around the synchronous formula. That is when NS is equals 120 multiplied by frequency over the number of poles, which is the relationship between speed and frequencies. So varying the frequency of the drives as per specification at intervals, the speed of the motor will also increases with respect to the varying frequencies.
In starter with moving switches, it is very difficult to vary the frequencies of the motor, while with starters with solid-state devices, the speed of the motor can be varied via electronic means.
Again, motors are usually terminated in two forms, which are in delta configuration or in a star configuration. The major difference between the two configurations is that, in star configuration, high voltage at low current will be supplied to the motor, while in a delta configuration, low voltage but higher current will be supplied to the connected motor. Now, before I will connect the metallic bars, it is important that to verify that the start of the U phase is truly terminated to U1, as it is tagged, and for the rest also. I will connect this battery here to the U windings. If it is truly connected properly, then when measured with a voltmeter, then our reading will be positive as seen here. V also gives positive readings. But the reverse is with W phase. That means that the connection is reversed. I will remove the tagged and properly terminate the trailing end of the coil. Otherwise, the operation of the motor will not be smooth, which is because of the order of the generated instantaneous current in the waveform.
Now, let's wire this motor using direct online starters method. The starter that we are using is the one with moving parts, and it consists of the following devices: contactors, circuit breakers, overload, and push buttons. And of course, looking at these schematics here, the schematic is divided into two, which are the power side and the control side.
It is important to note that the control circuit is used to control the power circuit. That is the opening and closing of the contactor when required.
So let me terminate the power side of the schematic to the electric motor and let's see. From the breakers, the three-phase conductor will be terminated to the incoming of the contactor, while from the outgoing of the contactor, it will be terminated to the overload. From the overload down to the electric motor. Andrea, flick the switch to the on position. The motor is not energized.
The reason why the motor is not energized is because the contactor is in open state. And of course by design. The contact of the contactor is usually in open states.
Now when we do a quick recap, it can be established that this is what differentiates between a domestic setup and an industrial setup. In domestic setup, contactors are not usually needed. Instead, it will be directly wired to the breakers, thereby leaving the motor to only one form of protection. And the flexibilities will not be there.
It is also important to note that, apart from the fact that the contactor is usually in an open configuration by default, contactor usually comes with auxiliary contact which also switches with the contactor. And on the auxiliaries contact, there comes multiple configurations in the following orders: normally open, normally close, and normally open. So when the coil of the contactor is energized, the contacts of the main change and also the auxiliaries also change too. That is, normally closed contact will now change to normally open, and normally open contact also changes to normally close.
Now, this contact is what we want to manipulate at intervals as per requirements. Andrea, terminate the control side and let's see.
It is important that we know the ratings of the contactor that we are using. Of course, contactors come in different ratings. We have contactors that are to be used with DC supplied. That is 24 volt, or the ones that are to be used on AC power supplied. That is 240 volts. In our case here, we will be using the ones that is rated 240 volts. And the coils of the contactors are terminated from A1 to one of the phases, while A2 will be terminated to neutral. So we will switch off the main breakers and terminate accordingly.
Now, let's switch on the main breakers and let's see. The motor rotates and this termination is not that different from our domestic termination. This does not offer some flexibility. Andrea, please add the e-stop, overload, and push buttons.
Now, instead of terminating this wire that is coming from the breaker directly to A1 of the coil of the contactors, we will allow it to go through all these devices. So we will terminate the wire to the terminal denoted 1 of the e-stop, and the other ends of the e-stop, which is denoted 2, will be terminated to 95 of the overload, and the end, which is 96, will be terminated to 1 of the push button. And the other end of the stop button, which is 2, will be terminated to 1 of the start button. And the 2 of the start button will be terminated to the A1 of the contactor coil.
It is very important to note that all the contact, be it the E-stop, overload, and down to the stop button are normally closed by default, while the contact of the start button is normally open by default.
Andrea, please push the start button. The motor energizes when the start button is pressed. But immediately after the button is released, the motor will stop.
The reason why this motor stop is because of the button types. It is a non-dent button. The contact of the button opens when the finger is released. Another way might be to use a spring-loaded button, which is a button that holds when the finger is released, thereby retaining the contact of the button.
Perfect, Laura. Of course. Although the motor will run, but it can also be achieved using that same non-spring-loaded button.
Yeah. This will be achieved by incorporating another circuit, which is known as retaining circuit.
I will switch off the main breakers, and I will connect one of the normally open contacts of the auxiliaries, which is 13, to be in series with the main contactor, and the other end, which is tagged 14, will be connected to the A1 of the contactor. Now when I switch on the main breakers, and when I push the start button, the contactor will be energized, and the motor will also be energized also. And when the finger is removed, the motor will stay energized.
The reason is, the auxiliaries contact retain the terminations, and it will only be de-energized when the stop button is pressed.
These terminations are what is known as direct online starters. Now, to make this termination to be a little more flexible and neater, all these can be converted into one of the IEC 61131-3 programming languages. And as such, we will only be having 2-wire terminations going to the contactors instead of all these terminations. This will be discussed in a later series. So direct online starters are usually used on an electric motor of lower rating. That is 1.5 kilowatts, 2.2 kilowatts motor, and so on. An electric motor that has a rating that is 7.5 horsepower or more, or 5.5 kilowatts or more. Star Delta starters are usually used for this type of motor. So we will be looking at Star Delta starters in our upcoming series. So that is it. I hope you have learned something new today. See you at the next one.